This is an EEG Basics mini lesson focusing on 14 and 6 Hz positive bursts. These are also known as 14 and 6 Hz positive spikes, or sometimes 14 and 6s. This is a normal EEG variant not thought to be associated with epilepsy or any other disease. These are relatively rare but important to recognize when interpreting routine and prolonged EEG recordings. If we look at this patient's recording, we can see that he is most likely asleep. This is indicated by the absence of a posterior dominant rhythm, the lack of any muscle artifact, and the fact that there is some diffuse intermittent theta activity, seen best at the start of the page. If we look at the center of the page, we can see the finding of interest. This is best seen in the temporal region on the right side, where there is a run of relatively high frequency, sharply contoured apiculate waveforms. These have a fairly broad field when looking at the entire page and are difficult to localize on an anterior-posterior bipolar montage. We can attempt to switch to an average reference montage, but again, because of the very broad field of this finding, it is very difficult to localize. Arguably, the waveforms are best characterized in the right posterior temporal region, but because of reference contamination in the broad field, there is apparent involvement of the left anterior temporal region, which does not make a lot of sense. Because of their broad field and complex distribution, one of the best montages to look at these waveforms is actually the contralateral mastoid montage. This montage is particularly helpful because if we consider that these findings are maximal in the parietal and posterior temporal region, one of the longest distances would be the contralateral mastoid. To get a better sense of the morphology and characteristics of these discharges, we can trace over them, focusing on the posterior temporal region where they are maximal. Initially, in this discharge, we see apiculate waveforms at a higher frequency, in this case 14 Hz, followed by a couple of broader discharges which are much slower at 6 Hz. This is how the name 14 and 6 comes. If we look at the sharpest component of these waveforms, we can see that it is downward deflected. This means that this is a positive polarity, and hence the name 14 and 6 positive bursts. If we look earlier in the page, we get a better sense of the mixture of 14 and 6 Hz discharges. Focusing in this area, we see that initially there is the higher frequency arch-shaped 14 Hz waveforms, but then there are broader waveforms that are at 6 Hz. These are sometimes notched in the middle, where you can see what is probably the remnant of the 14 Hz waveform. This is probably because of harmonics of two different waveforms which are superimposed on each other. And once again, it becomes easy to understand how the name 14 and 6 arose. One of the other names that has been given to this type of waveform is ctenoid. This comes from the Greek word for comb. It becomes easy to see how the people who first described this waveform arrived at this name. If we look at these runs of waves, we can easily see how they superficially resemble a comb. 14 and 6 Hz positive bursts are thought to be benign and not associated with epilepsy or any other neurological disease. They are most common in young people and probably peak in adolescence. They are less frequent as patients get older. As I mentioned before, one of the most important takeaways is to better characterize these bursts by switching montages. I would strongly recommend using a montage that has a distant reference, such as a contralateral mastoid montage, to best characterize these discharges.